In this video, we're going to look at how to graph the square root function. So normally when we've been graphing functions, we've started with the values of -2, -1, 0, 1, and 2. But I want to look at why we can't use those values with the square root function. So let's say we chose the x value of -1, and we plugged it into the function. That would give us y equals the square root of -1. Well, like we talked about before, we can't take the square root of -1 and get a real number. So we would say this is not a real number, and if something isn't real, it means we can't plot it on the coordinate plane. So we can't choose any negative x values here, which means the first x value we would be able to choose is 0. So if we plug that into our function, y is equal to the square root of 0, which is 0. So that's our first ordered pair, 0, 0. So right here at the origin. We can choose 1 because 1 is a perfect square. We can take the square root of that. So y is equal to the square root of 1, which is 1. So when x is 1, y is 1. So we also have a point at 1, 1 here. Now we could choose 2, but if we choose the square root of 2, that's going to be a non-repeating, non-terminating decimal, and that's going to be hard for us to graph. So this is actually an irrational number. And the same thing would happen with the square root of 3. That is also irrational. So what would make it easy is if we only chose perfect squares here, because then we'd have nice whole numbers to plot. So the next number that's a perfect square is 4, and we can take the square root of 4 to get our y value, which is 2. So we have a point at 4, 2. And then after that, the next perfect square would be 9. And we can take the square root of 9 and get a nice whole number, and that would be 3. So we have a point at 9, 3. And then we're going to run out of room on our coordinate plane, so I'm just going to choose those 4 values. We can plot those, and that is what our square root function looks like. Now, let's talk about the domain and range really quick. So if we're looking at our x values, our smallest x value is right here at 0. And then all of our values are headed to the right toward infinity. So the domain of this function is from 0 to infinity, and we use a bracket because 0 is included. And then if we look at the y values, again, our lowest y value is 0, and then all of our y values are slowly heading up toward infinity. So the range of this function is also 0 to infinity, and again, we use a bracket because 0 is included. So now we're going to take the square root function and we're going to apply the same transformations that we've talked about before. So in this function here, f of x is equal to the square root of x minus 3. We're going to start by just graphing our regular square root function. So this is the same table that we just talked about a minute ago. So we have the points 0, 0, 1, 1, 4, 2, and 9, 3. So this looks exactly like we just graphed, same points. And then this minus 3, because it is not under the radical with the x, is going to move all of those points down 3 units. So I'm just going to take each point and move it down 3. So it will look like this. So the shape hasn't changed. The rate that it's increasing hasn't changed. The only thing that's changed is we've just moved it down 3. So now let's look at our domain and range. So our smallest x value right here is still 0, and everything is headed to the right toward infinity. So our domain has not been affected by this change to the function. It's still from 0 to infinity. Now, if we look at our y values, though, our smallest y value is now -3, and everything is above that headed toward infinity. So the range is now -3 to infinity. And again, we're using brackets on both of those values because they are included. So now let's look at the square root of x plus 2. So this time what you should notice is that the plus 2 is underneath the radical with the x, which means it's going to be a horizontal translation. And remember, these do the opposite of the sign. So this means we're going to take square root of x and move all of those points to the left 2. So again, we're going to start with our original square root function, 0, 0, 1, 1, 4, 2, and 9, 3. And then we're just going to take each of those points and we're going to move them to the left 2 units. So everything just moves to the left 2. And this is our new graph right here in blue. So let's look at the domain and range here. So if we look at the domain, you can see that our graph starts at x equals -2, and then everything is headed to the right toward infinity. So our domain is from -2 to infinity. And then our range, our smallest y value hasn't changed. It's the same as the original function, y equals 0. And then everything else is headed up toward infinity. So our range is from 0 to infinity. Okay, so in this one we're going to have two transformations. So the first one is this -3 that is under the radical with the x. Again, that's going to be a horizontal translation, and it's going to do the opposite of what we would think given the sign. So this is going to move everything to the right 3. And then this +1 outside the radical all by itself is going to move everything up 1. It is a vertical translation. So again, we're going to start with our basic square root function at 0, 0, 1, 1, 4, 2, and 9, 3. And then now what we're going to do is we're going to take each one of those points and we're going to move them all to the right 3 and up 1. So here's our first point. Our second point overlaps. And then this next one will be a little bit off our coordinate plane, way over here. So our graph will look like this. So to the right 3 and up 1. So let's look at the domain of our new graph. So our smallest x value is now 3, and everything's headed toward infinity. So our domain is from 3 to infinity. And then our smallest y value is at 1, and again everything's headed up toward infinity, so our range is from 1 to infinity.